Hey guys, welcome to another video on budgeting. One of the major problem with the traditional budgeting is that it compares the actual results with the results which were set at the start of the budgeting process without making any allowance for the changes in the environment or the economy. Flex budget is a technique which resolves this issue. It converts the original budget as per the actual activity. For example, if the original budget was set for 10,000 units per month, it would convert the total cost of material, labor, and overheads, for example, for 11,000 units. 11,000 being the actual activity level. By doing so, it takes away any differences which may have arisen due to the increase in the productivity. The result would be comparing what we should have spent on material and labor and other expenses to produce 11,000 units versus what we actually spent on producing 11,000 units. Instead of an illogical comparison of what we should have spent on producing 10,000 units versus what we actually spent on producing 11,000 units. In this video, I will show you how to convert a traditional, also called fixed budget, into a flex budget. So let's read the question first, and then I will solve the question on Microsoft Excel. RPLC is an engineering company that repairs machinery and manufactures replacement parts for machinery used in the building industry. There are a number of different departments in the company, including a foundry, a grinding department, a milling department, and a general machining department. RPLC prepared its budgets for the year ending 31st December 2023 using an incremental budgeting system. The budget is set centrally and is then communicated to each of the managers who have responsibility for achieving their respective targets. The following report has been produced for the General Machining Department for October 2023. We can see that we have budgeted figures. This was the original budget which was set before October 2023, and then we have actual results which we receive after the end of October 2023, and then we have a variance. Now the variance is the difference between budgeted figures and the actual figures. So we estimated at the start of October that we will be running 9,000 machine hours. However, actually we ran 11,320 machine hours. Obviously, if you run more machines, then you are going to spend more money. So that was what happened here. So we can see that the cleaning material, the variance is adverse. Adverse mean is bad. We spent more than what we should have. Steel, we used more because we ran machines more. So again, the variance is adverse. Other direct materials, adverse materials. The first three items are direct material. Then we have direct labor, because we use machines more, so we had to use more machines. So the variance is again adverse for labor hours too. And then production overheads are more as well. As a result, the total variance is 27,640 adverse. So that means we have spent more money what we should have. In a situation where businesses are using fixed budget approach, this will not be allowed. And one of the reasons for that is cash availability. So what they do, if they think that the cash will not be available or there's a limited supply of finances, then they make sure that the managers do not exceed the given budget so that the organization do not struggle financially. However, that would result in low productivity, which is one of the biggest problem with traditional budgeting, that it hinders growth. So if this manager would try not to exceed the cost, they would not accept any orders more than 9,000 machine hours. The manager of the general machining department has received a memo from the financial controller requiring him to explain the serious overspending within his department. The manager has sought your help, and after some discussion, you have ascertained the following. The cleaning materials, steel, and other direct materials vary in proportion to the number of machine hours. So they should vary in the same proportion with the difference in the hours. The budgeted direct labor cost includes fixed salary cost of £4,250. The balance is variable in proportion to the number of machine hours. The production overhead cost include a variable cost that is constant per machine hour at all activity level, and a stepped fixed cost which changes when the activity level exceeds 10,000 machine hours. A further analysis of this cost is shown below. We have three different activity levels, machine hours, and then we have associated cost of running that many machine hours. We can see that at 3,000 the cost should be 13,500. For 7,000 it should be 24,500, and for 14,000 units it's 45,800. One thing must be noted here, that from these three activity levels, there are two activity levels, 3,000 and 7,000, which fall below the 10,000 activity level limit. This means that our fixed cost will be same at 3,000 and 7,000 machine hours. However, it will be different from more than 10,000 units. So at 14,000 level, it will be different. The reason this data is given is because it can help us to calculate the fixed cost, variable cost per unit of the organization, which can be helpful to determine how much we should have spent on production overheads for actual level of activity. I have dealt with this problem before in my another video, which is high-low method. So if you haven't watched that video yet, please watch that video first, because that would help you to understand what is happening here. The requirement for this question is to prepare a revised budgetary control statement using the additional information that you have obtained from the manager of the general machining department. If we apply all of the information which we have from the question, we would have prepared a flex budget, which is the requirement for this question. So our fixed budget was 9,000 hours. Our flex budget will be prepared for actual hours. So 11 to 20. The variance, volume variance should be 0, and there is no applicable here. So first of all, flex budget will be prepared for the actual activity. That's the one change so far which I have done to the question. I simply copied the data from my question. The marks which you will get is for finding out this column. So that's the figure. These are the figures that you're looking for. These are the figures which you need to work out. And then for these two columns. half a mark each row basically. And for this, you're gonna have to do working. So it's important that you guys do workings for each bit so that it's clear. Your answer is clear. So let's. Okay, what we can do here is we can simply place actual data from the question. So it's the thing which can be done straightforward. Okay, so first of all, cleaning material is variable, steel is variable, other direct material is variable. So I'm going to do my working one. So working one, cleaning material. Per machine hour, what I can do is I can calculate how much does it cost per machine hour on the cleaning material. So my original budget was $13.50 and my original hours were 9,000. So cleaning material per machine hour are 15 pence. This means that when we make a budget, we said for 9,000 hours, we are going to spend money of 1,350 pounds on cleaning materials. So if we go back and revise our budget for 11,320 hours, we would need 1,698 pounds for cleaning material. So we are revising our original budget as per, for original estimate. So 1,698 is my budget for my actual hours. Cleaning material is a variable cost. So for 9,000 hours is 1,350. For 1 hour is 15 pence. Okay. Yeah, 1 hour is 15 pence. My working steel is for steel. So cost on steel is £5 per machine hour. For actual activity, So we are not even looking at our actual results now. At the moment, we're ignoring actual results altogether. At this stage, we're only taking into account the actual activity, and that's it. Actual results we only do when we look at the third and the fourth column. So there's no link between these budgets at the moment and the actual result. This is what we calculated before we have done the activity, assuming that we changed our budget from 9,000 to 11,320. Yeah. So rather than what you said, we can say that for 9,000 hours, our cost was 45K, and now for 11,320 hours, our cost is 56.6K.
Okay.
Other direct materials working free now is other direct material. £5 per hour. Direct material cost is £5 per hour. We will simply multiply this figure with 11,320 to get the estimated or budgeted cost for our actual activity. Okay, so now we have labor, direct labor working for. So direct labor. Total direct labor cost is 29,000. Fixed cost is 4,250. That means that variable cost is 2,470. So that's step one. First of all, you get your variable cost. Once you get your variable cost, it's just like steel or other direct material cost. You get per unit first, and then you multiply that with the actual cost. So we estimated, when we were preparing our original budget for 9,000 hours, we estimated that the variable cost will be 2,450. All we have to do is revise our budget now to 11,320 and get a new figure for that. So, variable cost per hour, or machine hour, 2,450 divided by 9,000 hours equals divided by 9,000. £2.75. I want all of us can hear you. Okay. So, for 9,000 hours, our variable cost would be 24,750. For 11,320, our variable cost would be 31,130. You need to add back fixed cost now to get the total cost. And the total cost which we should be spent for 11 to 20 hours is 35,380. Okay, so the production overhead costs are given 30,000 pounds, right? For 9,000 hours, 30,000. Some of it is fixed, some of it is variable, and we don't know how much is fixed, unlike direct labor. So we need to calculate all of these costs now. So we need to use Hilo method. We have 3,000, 7,000, and 14,000 activity. One thing we need to remember, very critical, that step fixed cost adds into this after reaching 10,000 hours. So the fixed cost will be exactly the same at 3,000 and 7,000 hours, and it will be different for 14,000 hours. What is critical here, that when you choose two activity levels, high and low, you choose the same fixed cost level. So in this case, 3,000 and 7,000 have the same same fixed cost, while 14,000 has a different fixed cost. If you choose 3,000 or 14,000 or 7,000 or 14,000, you're gonna get a wrong answer. You need to get exactly the same fixed cost one, which is 3,000 and 7,000. So we will pick 3,000 and 7,000 as our high and low activity, and we are going to work this out. So let's work out our variable cost per unit first. Working 5. So working on production overheads. So first of all, step 1 gives us variable cost per unit per hour. And for this, we need to have cost at high level, 24500 minus 13500 and 7,000 minus 3,000. So I have picked two activities. One is 7,000 and the other one is 3,000, and their corresponding costs. The difference can be calculated. $24,500 minus $13,500, 11,000, and 7K minus 3K, 4K, and the variable cost is 2.75. It's just a coincidence, guys, that this 2.75 and this 2.75 is same. It doesn't have to be same. Times already fixed cost equals total cost minus variable cost per unit, which we just calculated, 2.75 into number of units. To solve this equation, we need to choose an activity level. Okay. And again, we need to make a decision here. Which activity level to be chosen? the actual activity level is 11,320, which is above 10K, yeah? So that means the fixed cost will be different at 11,320 and 7,000 and 3,000. We have a cost 14,000 activity level where the fixed cost will be same as 11,320. So we should choose, generally I say you can choose any activity level and you will get the same answer. But because there's a step fixed cost element, you need to choose exactly the same range. Yeah. So 14,000 and 11,320 is in the same range. So you're gonna have to choose 14K. Yeah. So for 14,000 hours, we are looking for fixed cost there. Our total cost is 45800 minus 14,000 units times 2.75 per unit, and that's our variable cost. $7,200. The fixed cost at 14K and at 11,320 is exactly the same. 7,300. So we can assume that the fixed cost will be the same at 11,320. So now we know the fixed cost at 11,320. We need to find out variable cost. We can add them together and we can get our answer for the table up there. So for 11,320 hours, my total cost is what I'm looking for. My fixed cost is 7,300. That's I just calculated, plus 11,320 times 2.75. Ooh, made a mistake. Where?
Put times instead of plus.
Yes. Plus 38430, and that's my answer, which I need to insert into my. So what basically we have done just for production overheads, we originally estimated that if we run 9,000 hours, it's going to cost us, as per the question, 30,000 pounds. So we have adjusted that figure for our actual activity. So for 11,320 hours, we should spend 38430. So again, is our budget. So that's a major part of the question has been answered. Now simple subtraction and making a decision if it's favorable, and it was favorable means if it's good for the company, adversely if it's bad for the company. Spending more money is bad for the company. Saving money is good for the company. Okay? So in our original question, everything is adverse because we spent more than what we were allowed to. But if we revise it and use a different concept, let's see what happens. So I'm going to subtract from what we were allowed to and what you've actually done. Budgeted minus actual. Spent more, critical to understand, spent more money than you were allowed to. Adverse. Spent more money than you were allowed to. Adverse. Spent less money than we were allowed to, so that's a good thing, favorable. Spend more money, adverse. Spend less money, favorable. And spend more money, adverse. The final variance is adverse as well, but it's not as bad as it looked in the original question. In question, you have to explain 27,640 pounds worth of variance. Now you have to explain only 7,766 pounds.